Well, folks, welcome to the Crazy Hat Chemist. So here we go with another video here. This time it will be the following: Introduction to Types of Chemical Reactions. And this is going to be for my general chemistry course. So here we go. Here's a worksheet of which I've designed. So let's get moving through it. Here we go. Sadly, I'm going to read some of this here, and that will be hopefully helpful for you as you follow along. All right, here we go. In chemistry, there are 5 generic chemical reactions, and the vast majority of chemical reactions fall under these 5 different types. These 5 types of chemical reactions can be further subdivided. However, this introduction will only focus on the 5 generic types and not their subdivisions. Firstly, a chemical reaction is a summary or shorthand expression of how atoms, molecules, or ions are rearranged to form new substances. The substance or substances that enter a chemical reaction is or are called the reactant or reactants, whereas the substance or substances that exit a chemical reaction is or are called the product or products. A chemical reaction is read from left to right with the reactants on the left and the products on the right, separated by an arrow. The reactants and the products are written using chemical symbols. If there are multiple reactants or products, then they are separated by a plus sign. A key feature of the representation of a chemical reaction is that atoms are not created or destroyed. This is indicated by coefficients, which are whole numbers in front of chemical formulas to balance the number of atoms on both sides of a chemical equation. The last component of a chemical reaction is that each formula includes its state of matter after the formula. For example, if it is a solid, liquid, or a gas. The 5 types of chemical reactions are: number 1, double displacement or replacement. Another name for this is a metathesis. Number 2, single displacement, single replacement, or a substitution. Number 3, combustion. Number 4, decomposition. Number 5, combination or synthesis. Below is a summary of the key components of each type of chemical reaction and how to distinguish each from another. The double displacement or double replacement is also known as a metathesis. This type of reaction is characterized by having 2 reactants, of which each is composed of a cation and an anion. Furthermore, there are 2 products, each composed of a cation and an anion. However, the products are different than the reactants, and usually there is some indication that a reaction has occurred with one of the following: heat production, as in a neutralization or a precipitation, the formation of a solid, or the product of a gas. Below is a general format of this type of reaction. So let's scroll this up forward here so that I can show you all those different types here at this moment in time. Okay. All right. How's everyone doing so far on this? Hopefully we're doing good. All right. Perfect. All right. So here we go. AB plus XY yields AY plus XB. You should see that the reactants are on the left-hand side of the arrow, and the products are on the right-hand side of the arrow. Furthermore, I'll do a little bit of color coding. You should see that A on the reactant side will combine, which is a cation, and will combine with Y on the product side. And then X, which is a cation, will combine with B on that other side there. So understanding this, that is a cation is positive, an anion is negative, a cation is positive, an anion is negative. And you might be wondering, why is A first? Why is X first? Because cations are always written first, anions are always written second, just like that. All right. Here are some examples of double displacement or double replacement reactions. Here's a neutralization reaction, that is NaOH, that's sodium hydroxide, that is aqueous, plus hydrochloric acid, that's aqueous, yields sodium chloride, aqueous, and H2O, that's water, as HOH, that's a liquid plus some heat. So you should see that this sodium combines with that chloride to form sodium chloride, and this hydrogen combines with that hydroxide to form water, H2O. Notice also that the cation is always written first, the anion is written second, the cation is written first, the anion is written second. And that is the same with both of the reactants as well. The cation is written first, the anion is written second. Okay, perfect. Let's do another one. Here's a precipitation type of reaction. That's barium nitrate. That's aqueous plus sodium sulfate. That's aqueous. Those are the two reactants. That yields two products. That's sodium nitrate and barium sulfate. And a precipitation reaction is when a solid is formed on the product side. This one requires a stoichiometric coefficient of a 2 right here for the sodium to balance it out. Okay, here's a production of a gas, and that is hydrochloric acid plus zinc sulfide yields zinc chloride and hydrogen sulfide, and this is a gas-producing reaction as hydrogen sulfide is a gas. Perfect. So that is right there. 3 examples of double displacement, double replacement reaction. So let's scroll this on up and we'll do the next type of reaction. Okay, here we go. Perfect. Says the single displacement or single replacement is also known as a substitution reaction. This type of reaction is characterized by having 2 reactants, where one is composed of a cation and an anion, and the other is an element. The products follow the same pattern as the reactants. That is, you'll have a cation anion plus an element. There are 2 subdivisions of this type of reaction, one with the element being a nonmetal and the other with the element being a metal. The 2 general formats for this reaction are shown here. We have AB, and that is the cation anion. There's an element that's a nonmetal, and this nonmetal will displace the B, which is an anion. Then that B will now be an element all by itself, and then you will still have a cation anion on the product side. Or the other possibility is you have a cation anion, and you have an element that is a metal. That metal will displace the cation. The cation will now be by itself as an element, and you will have YB, which is a cation anion combination. Here are some examples of single displacement or single replacement or substitution reactions where the element is a nonmetal. Here's the element as a nonmetal. It will displace the bromine if it's more reactive. Bromine will be the element by itself, the cation anion, and then we have an element. So it's following the same pattern. The other option here is when we have magnesium. Magnesium is a metal. It will displace the cation, and then the cation will be an element that will be by itself. You have a cation anion, and element. That is the pattern of a single displacement. You should see that it required on this first reaction a 2 stoichiometric coefficient here in those places for balancing, and in the second one a 2, a 3, a 2, and a 3 for stoichiometric coefficient balancing on those. Perfect. That is the single displacement, single replacement, or substitution reaction. All right, let's give it a try for our next reaction type here, and it is the combustion reaction is characterized by having a compound composed of carbon and hydrogen, or a compound composed of carbon, hydrogen, and oxygen, plus molecular oxygen to produce carbon dioxide and water. Heat is also necessary to make the reaction proceed forward, indicated by the delta, which is a triangle above the arrow. Furthermore, these reactions produce heat and are therefore labeled as exothermic. The two general formats for this reaction are shown below. So let's see if we can do that. X and Y. X and Y can be any number, and that's a carbon and a hydrogen plus a molecular oxygen, that's gas. There's that delta above the arrow, that's requiring heat. These are the two reactants. Carbon dioxide, which is a gas, and water, which is a liquid, are the two products. Or the other possibility is carbon, hydrogens, and oxygens, where X, Y, and Z can be any number, plus molecular oxygen, that is a gas, produces carbon dioxide and water. Carbon dioxide is a gas, water is a liquid. Heat is required to make this reaction go forward. These are exothermic reactions, that is, they produce heat. Here are two examples of combustion reactions. A CX combustion. This is butane, and this is C4H10, it's gas, plus molecular oxygen yields carbon dioxide and H2O, that's water, that's a liquid. This requires some stoichiometric coefficients, 2, 13, 8, and 10, of which we will get into stoichiometric coefficients in another video. Another example is when we have CHNO in a combustion type of reaction. This is C3H7OH. This is an alcohol plus oxygen yields carbon dioxide and water. This also has stoichiometric coefficients. This is a 1 right there that's assumed. There's a 5, a 3, and a 4. Again, the stoichiometric coefficients is something that we'll cover in another video. Okay. Both of these, you have a delta, which is the Greek letter delta, and that is the triangle symbol that's above the arrow that is necessary for this reaction to proceed from reactants to products. That's essential. All right, let's get into the next type of reaction. That next type of reaction is going to be the decomposition or analysis type of reaction. Is characterized by having a single reactant and two or more products. The decomposition is the reverse of the next reaction, the combination or synthesis. Typically, the decomposition reaction yields one of the products as a gas, and the other product is either a cation-anion combination or an element. Additionally, the reactant is most commonly a solid. The gas is most commonly one of the following: O2, CO2, or SO2. The two general formats of this reaction is shown below. XY yields X plus Y. And these decomposition reactions also require heat, that is, that delta above the arrow. Or XYZ yields, again, requiring heat, XY plus Z. So this X would be an element, and this is clearly a gas. This is a cation anion, and this is clearly a gas. Here are two examples of a decomposition reaction. So let's scroll this on up so that we can see these. The products are both elements and one is a gas. So this is mercuric oxide, which is a solid. It requires heat for this reaction to proceed forward. And you get mercury, which is a liquid, plus molecular oxygen. This one requires some stoichiometric coefficients, 2, 2, and a 1. And then another example is one product is a cation anion and the other is a gas. You have potassium chlorate yields potassium chloride, which is a solid, and molecular oxygen. This also has stoichiometric coefficients of a 2, a 2, and a 3. Again, stoichiometric coefficients is something I will cover in another future video. We're going to scroll this up to go for the next type of reaction. Here we go. The combination or synthesis type of reaction is characterized by two reactants yielding one product. This reaction is opposite that of the decomposition reaction. Most commonly, one of the reactants is a gas. There are two general formats for this type of reaction as shown below. With the second example, a special case where a gas is bubbled into water to produce an acid. So we have X plus Y. Y is a gas, yields X and Y. Or we have AO, that's a gas. This is most commonly a non-metal plus water, and that gives that gives HAO, and this is an acid. Okay, here are two examples of combination reactions. One reactant is a gas, so we have aluminum solid plus molecular oxygen gives us aluminum oxide. Again, we have some stoichiometric coefficients of a 4, a 3, and a 2. That balances the reaction. The production of an acid with a gas and water as reactants. So we have sulfur trioxide is bubbled into water that's a liquid, and you get sulfuric acid. Fantastic. All right, so here's going to be just a little bit of a recap here to figure out if we got everything right. So let's see what we can do in answering these 8 questions at the bottom here as a little summary. So here's our questions. How many different types of generic chemical reactions are there? There are 5. Okay. An arrow separates the reactants from the products. The reactants are on the left-hand side of the arrow. The products are on the right-hand side of the arrow. Coefficients are used to balance chemical equations, which are whole numbers in front of formulas. These are actually specifically called stoichiometric coefficients, but just to make sure, at this moment in time, we'll just call them coefficients. A reaction that always produces carbon dioxide and water is a combustion. A reaction most commonly produces heat, solid, or a gas is a double displacement or a double replacement or a metathesis. A reaction always has one product. That is a combination or a synthesis. A reaction has only one reactant. That's a decomposition or an analysis. A reaction that has a cation, anion, and an element. So that is a single displacement or a single replacement. Hey, hopefully you have learned something generically about the 5 different types of chemical reactions. I am the Crazy Hat Chemist, and I would most appreciate if you subscribe to my YouTube channel and give me a thumbs up, give me some comments. I'll answer your comments, and would greatly appreciate that. I hope you have a fantastic day, and hopefully you have learned something very well here today. And I will see you for next time. Bye for now.